Imagine this, a massive asteroid, a cosmic juggernaut the size of a city, screaming through space at tens of thousands of miles per hour. It's not just a rock, it's a harbinger of chaos, hurtling toward Earth with enough energy to rival thousands of nuclear bombs. The moment it strikes, the world changes. The sky darkens, not with clouds or night, but with a choking veil of ash and debris. The ground trembles, splitting open in places long thought stable, and then, one by one, volcanoes across the globe dormant for centuries or even millennia begin to roar to life, spewing molten rock and toxic gases into the atmosphere. This isn't science fiction, it's a chilling possibility rooted in the physics of our planet. What if an asteroid impact could trigger a global volcanic cataclysm? Let's dive into this terrifying scenario, unpack the science, and face the consequences for life as we know it. Picture a cosmic billiard ball slamming into Earth. The impact is catastrophic, a spectacle of destruction that makes even the largest earthquakes seem trivial. When an asteroid, say, 10 kilometers wide, like the one that ended the dinosaurs 66 million years ago hits, it doesn't just carve out a crater. It unleashes a cascade of effects that ripple far beyond the impact site. The energy released is staggering, equivalent to billions of tons of TNT. The ground vaporizes at the point of contact, sending a shockwave through the Earth's crust and mantle like a stone dropped in a pond. Trees are incinerated for hundreds of miles, and a plume of molten rock and debris shoots into the stratosphere, blocking sunlight for months or even years. But here's where it gets wild. Could this single, cataclysmic strike do more than just scar the surface? Could it wake up the planet's sleeping giants, its volcanoes? To answer that, we need to think about what an impact does to Earth's interior. The Earth isn't a solid, unyielding sphere, it's a dynamic, layered system. Beneath the crust lies the mantle, a semi-fluid layer of molten rock that's always churning, albeit slowly. The impact's energy doesn't just stop at the crater's edge, it propagates through the planet, sending seismic waves that could, in theory, rattle fault lines and volcanic systems thousands of miles away. Scientists have long studied how impacts transfer energy. For example, the Chicxulub impact, which formed a 150-kilometer wide crater in what's now Mexico's Yucatan Peninsula, released energy equivalent to 100 teratons of TNT. That's enough to trigger earthquakes of magnitude 10 or higher, far beyond anything humans have ever recorded. These seismic waves could destabilize tectonic plates, fracture the crust, and most crucially disturb magma chambers beneath volcanoes. Think of it like shaking a bottle of soda. The pressure builds and something's gotta give. So could an asteroid really set off volcanoes worldwide? The short answer is, it's plausible, but it's not a simple yes or no question. Let's break it down. Volcanoes erupt when pressure in their magma chambers overcomes the strength of the surrounding rock. This can happen naturally over time as magma accumulates, or it can be triggered by external forces like earthquakes. An asteroid impact is essentially a super earthquake, delivering a colossal jolt to the planet's crust and mantle. Recent research, like studies published in Nature Geoscience, suggests that large impacts can indeed influence volcanic activity. The Chicxulub impact, for instance, is thought to have intensified volcanic eruptions in India's Deccan Traps, a massive volcanic province that was already active at the time. The theory goes that the impact's shockwaves traveled through the Earth, squeezing magma chambers and fracturing rock, effectively priming volcanoes to erupt. In a worst-case scenario, a large enough impact could destabilize multiple volcanic systems, especially those already on the brink of eruption. But here's the kicker: Earth has thousands of volcanoes, from the iconic Mount Vesuvius to the sprawling Yellowstone supervolcano. Not all of them are equally sensitive to a seismic nudge. Active volcanoes, like those along the Pacific Ring of Fire, are already primed with molten magma, making them more likely to respond to an impact's shockwaves. Dormant volcanoes, like Yellowstone, might need a bigger push, but their massive magma chambers could make them catastrophic if triggered. Submarine volcanoes, which make up a huge portion of Earth's volcanic activity, could also erupt, potentially causing tsunamis and releasing vast amounts of gas into the atmosphere. The mechanism is complex. Seismic waves from an impact could fracture the crust, creating new pathways for magma to rise. They could also disrupt the delicate balance of pressure in magma chambers, triggering eruptions. In some cases, the impact might even shift tectonic plates, reactivating fault lines and sparking volcanic activity in regions thought to be stable. The bigger the asteroid, the more energy it delivers and the more widespread the effects. A 10-kilometer asteroid might trigger regional eruptions. A 50-kilometer monster could, in theory, set off a global volcanic chain reaction. Let's paint the picture of what happens next. The asteroid hits, let's say, in the Pacific Ocean, just to make things extra messy. The initial impact creates a crater hundreds of miles wide, vaporizing seawater and sending tsunamis racing across the globe. The shockwaves ripple through the Earth, rattling tectonic plates from California to Japan. Within hours, volcanoes along the ring of fire Mount Fuji, Krakatoa, Mount St. Helens begin to rumble. Magma chambers, already pressurized, find new cracks to exploit, and eruptions begin. Ash clouds billow into the sky, blotting out the sun. In Yellowstone, the supervolcano stirs, its massive caldera fracturing as magma surges upward. The atmosphere becomes a toxic soup. Volcanic eruptions release not just ash but sulfur dioxide, carbon dioxide, and other gases. Sulfur dioxide forms aerosols that reflect sunlight, plunging the planet into a volcanic winter. Temperatures drop by several degrees, crops fail, and ecosystems collapse. Meanwhile, carbon dioxide adds to the greenhouse effect, setting the stage for long-term climate chaos. The oceans, already battered by tsunamis, become more acidic as volcanic gases dissolve into seawater, killing marine life. The human toll is unimaginable. Cities choke under ash falls, with particles so fine they infiltrate lungs, causing widespread respiratory illness. Infrastructure crumbles, roads crack, power grids fail, and airports become useless as ash clogs jet engines. Food shortages spark riots, and governments struggle to maintain order. If submarine volcanoes erupt en masse, tsunamis could wipe out coastal cities, displacing millions. Weeks turn into months, and the world is unrecognizable. The sky remains dark, a perpetual twilight caused by ash and aerosols. Global temperatures plummet, mimicking the aftermath of the Chicxulub impact, which some scientists believe triggered a decade-long cooling period. Photosynthesis slows, starving plants and the animals that depend on them. The food chain unravels and mass extinctions begin. Humans, adaptable as we are, face a grim reality: limited food, contaminated water, and a climate that swings between freezing winters and scorching summers as the planet tries to stabilize. But it's not just the immediate effects. The long-term consequences could reshape Earth for millennia. Massive volcanic eruptions, like those of the Siberian traps 250 million years ago, have been linked to mass extinctions that wiped out 90% of life on Earth. The combination of an asteroid impact and global volcanism could push the planet into a similar crisis. Carbon dioxide from eruptions could trap heat, leading to a runaway greenhouse effect once the volcanic winter subsides. Sea levels could rise, flooding low-lying regions. New volcanic landscapes, craters, lava fields, and ash deposits could render entire regions uninhabitable. Here's the big question: could humanity survive this? The answer depends on our preparedness and resilience. Underground bunkers, like those proposed for nuclear war, could shield small populations from ash and extreme weather. Advanced filtration systems could provide clean air and water. Hydroponic farms might sustain limited food production, but these solutions require foresight, resources, and cooperation, things humanity doesn't always excel at in a crisis. The geological record offers sobering lessons. The Chicxulub impact, combined with Deccan Traps volcanism, likely drove the dinosaurs to extinction. Smaller mammals survived, but only because they could burrow and scavenge in a world of scarcity. Humans, with their technology and adaptability, might fare better but not without catastrophic losses. Billions could perish in the initial chaos, and rebuilding would take centuries. Before we spiral too far into Doomsday, let's ground this in science. The idea of an asteroid triggering global volcanism isn't pure speculation, but it's not a guaranteed outcome either. The size, speed, and location of the impact matter. A smaller asteroid, say, 1 kilometer wide, might cause regional devastation but lack the energy to trigger widespread eruptions. A larger one, like the Chicxulub impactor, could push the planet's volcanic systems into overdrive, especially if it hits a tectonically active region. Studies, like those from the University of California, suggest that impacts can amplify existing volcanic activity but may not trigger dormant systems unless they are already close to erupting. The Deccan traps, for example, were active before Chicxulub, and the impact likely accelerated their eruptions rather than starting them from scratch. A truly global volcanic chain reaction would require an extraordinarily large impact, perhaps a 50-kilometer asteroid or bigger, combined with the planet already primed for tectonic upheaval. This scenario is a stark reminder of Earth's fragility. A single cosmic event could unleash forces we can barely comprehend, from shockwaves that shake the planet's core to eruptions that choke the skies. It's a humbling thought. For all our technology, we're still at the mercy of geological and cosmic forces, yet it's also a call to action. By studying asteroids, monitoring volcanoes, and preparing for worst-case scenarios, we can mitigate the risks. NASA's DART mission, which successfully deflected a small asteroid in 2022, shows we're not helpless. Early warning systems, like those tracking near-Earth objects, give us a fighting chance to act before disaster strikes. So next time you look at the stars, remember, they're not just beautiful. They're a reminder of the cosmic wild card that could, in an instant, set our world ablaze. Let's hope we're ready if that day ever comes.